So Natalie, here's a video on some of the problems that you sent me. The first one is number 41, and you have 3 over x plus 4 plus 6 over x plus 5. And so before we start this problem, I want to remind you of a couple things. First of all, to add fractions, you need a common denominator, and that denominator will always have to come from the two denominators that you're already working with. And in this case, x plus 4 and x plus 5, they don't have anything in common, so we're going to have to use both of them for our common denominator. In other words, we have to account for the x plus 4, which is underneath the 3, so I'm going to put x plus 4. We also have to accommodate for the, account for the x plus 5, which is the denominator on the second fraction. So I'm going to put those two together. I don't have to multiply them together. I'm actually going to just let them sit. And then I'm going to say to myself, what did I multiply the first denominator, the x plus 4, by to turn it into x plus 4 times x plus 5? In other words, what do you see in our new denominator that wasn't in the denominator underneath the 3? And what I see there is an x plus 5. So since I multiplied the bottom by x plus 5, I have to multiply the top by x plus 5. So I'm going to have 3 times x plus 5. Then I'm going to bring down my plus sign. And now I'm going to compare the second denominator, the x plus 5, to the new denominator. And I'm going to say what is on the bottom now that wasn't there originally underneath the 6. And that would be x plus 4. So if I multiply the bottom, the x plus 5, by x plus 4, then I have to multiply the top by x plus 4. So that's going to give me 6 times x plus 4. Now I have to simplify this. So on the top, I'm going to go ahead and distribute the 3 through the parentheses, and I'm going to distribute the 6 through the parentheses. So 3 times x is 3x, plus 3 times 5, which is 15. I'm going to bring down that plus sign. 6 times x is 6x. 6 times 4 is 24. And this is all still over my common denominator of x plus 4 times x plus 5. And again, you do not want to multiply that bottom together. Just leave it as those two binomials. Now the top, I can do one more thing. I can clean it up by combining like terms. So I have a 3x, and I have a positive 6x, so that's going to give me a total of 9x. And then I have a 15, and I have a positive 24, so that's going to give me positive 39 that I'm going to add on to that. And then the bottom is going to stay x plus 4 times x plus 5. And there's really nothing else you can do with this. You don't need to multiply the bottom together. The top doesn't have a GCF that you can factor out. So this is your final answer, 9x plus 39 divided by x plus 4 times x plus 5. And that should be in the back of the book so you could check your answer there. So we'll look at another one. Let's look at 45. So I'm going to stop this and put 45 on the next slide. Okay, Natalie, so here's number 45. And again, I have two different denominators. I have x plus 2 and I have x minus 2. So when I go to decide what my common denominator is so that I can add these, I have to account for both of those. I have to account for the x plus 2 and I have to account for the x minus 2. Then I have to compare my old denominator for each fraction separately with the new one. So the old denominator for the first fraction is just x plus 2. So if I compare x plus 2 to the bottom, which has an x plus 2 and an x minus 2, I've added an x minus 2. So I have to multiply the top, that 2x, by x minus 2. So I'm going to do that. Then I come to a plus sign. I'm going to bring that down. Then my next denominator is x minus 2. And when I compare that to the bottom, I see that there's an x plus 2 on the bottom of my new denominator right there that is not up here. So that means this top part has to get multiplied by x plus 2. So I'm going to write x plus 2 times x plus 2. Now I have to clean this up a little bit and do some multiplication. So I'm going to distribute the 2x to both terms in the first set of parentheses. So I'm going to get 2x squared minus 4x. And then I'm going to add to that. And now if I FOIL the next one, I have to distribute the x to both terms in the parentheses, and then I have to go back and distribute the 2 to both terms in the parentheses. So if I do the first one, I'm going to do x times x, which is going to give me x squared. And then the next one is going to give me 2x, and the next one is going to give me 2x. So outside is going to give me 2 times x, and inside is going to give me 2 times x. So that's going to give me a 4x in the middle. If you have to do that separately, do it separately. And then last is going to give me 2 times 2, so that's also 4. And then on the bottom, I just have my x plus 2 times x minus 2. And I'm not going to multiply that together. I'm just going to let it sit. And then the top, I need to clean it up. I need to look for like terms that I can add. So the first term I have is quadratic. I have a positive 2x. I also have another positive 1x squared, a 2x squared and a 1x squared, which is a total of 3x squared. Then I have a minus 4x, and I have a positive 4x, which means those are going to cancel, so I won't have an x term. And then the only other thing I see here is a plus 4, so I'm going to go ahead and bring down the plus 4. So I have 3x squared plus 4 on the top, and then I have x squared plus 2 times x squared minus 2 on the bottom. And I'm done. The top doesn't have a GCF I can factor out, and I don't need to multiply the bottom back together again. So that's number 45. Here's number 61, Natalie. You have a complex fraction, and you have to simplify it. We call it a complex fraction because you have fractions within a fraction. So in the numerator, notice you have a 1 over x, and in the denominator, you have a 1 over x. The top is a plus, and the bottom is a minus. But you've got these smaller fractions within the larger, the big fraction, okay? So I'm going to go ahead and erase and clean that up. I just wanted to point that out to you. So we have to get rid of those smaller fractions. So what you're going to do is you're going to look at what the denominator of the smaller fraction is. And in this case, it's an x. And I want to get rid of that. We're dividing by x, both top and bottom, so we're going to multiply by x. But when we do that, we have to do it to all the terms. And you have 1, 2, 3, 4 different terms. They all have to get multiplied by the x so that we can wipe out the fraction everywhere and treat all of the terms the same, okay? So I'm going to multiply the 1 by x. I'm going to multiply the 1 over x by x. And that x goes in the top with the numerator, not with the denominator. The 3 is going to get multiplied by x, and the 1 over x on the bottom is going to get multiplied by x. So if I do that, 1 times x is x. 1 over x times x I can cancel, and that just becomes plus 1. Bring down my fraction bar. 3 times x is 3x, and the x's top and bottom here will cancel, so I just have a minus 1. And now you can see you still have a fraction, but you don't have those smaller fractions within your larger fraction. This doesn't simplify any further, so you're done. So let's take a look at number 63. Now you have 2 smaller fractions, a 1 over y and a 1 over x within your larger fraction, okay? We have to get rid of both those smaller fractions. Now the denominators aren't the same. You have an x and you have a y. So what we have to do there is we have to get rid of both the x and the y. So everything, all 4 terms, you have 1, 2, 3, 4 terms. Every single one of those has to get multiplied by both x and y. So let's do that. So if I do that, I'm going to have 1 over x if I multiply that by x. Remember, that's on the top. But I also have to multiply it by y. Here I have to multiply by x and y. The y has to get multiplied by x and y. And the x has to get multiplied by x and y. Okay? So now, if I go to the top, the x on the top that I'm multiplying by will cancel the x on the bottom. And the only thing left there to multiply is 1 times y, which is y. Then I have a plus sign. I'm going to bring that over. And now the second fraction, I have a y that I'm multiplying by and a y that I'm dividing by, so I can cancel those. And I just have x times 1, which is x. And now I'm going to go to the bottom. And this first term, I have x times y. So I'm going to call that x squared y. And then I had a plus sign, which I know I've kind of blocked out, but I had a plus sign there, so I'll bring that over. And then I have x times y times y, so that's going to be x y squared. And I am actually done. I really can't do anything else with this. I can't cancel out any of the x's or any of the y's because none of these 4 terms have anything in common. In other words, all 4 of them would have to have the x, or all 4 of them would have to have a y for you to cancel it. So this is your final answer. I hope this helps, Natalie. We can talk tomorrow. Have a good day.